Hello, this is Complist, an AI compliance document analyzer, and it's our capstone project.
My name is James Todd. I contributed to the project with a local machine learning approach using a Python microservice.
My name is Mo Karaki. I contributed to the UX UI design. I created a Figma implementation and converted it to front end. I also worked on the back end, unit testing, and database schema.
I'm Andrew Brown. I contributed to backend development for users and document implementations.
I'm Justin Ho, and I also worked on both front end and back end developments, as well as testing and database setup.
Today, our motivation is to address a key challenge in compliance management. Many companies still rely on manual review of policies to determine whether they align with regulatory frameworks. The process is time-consuming, inconsistent, and often prone to human error. Our objective is to create a user-friendly, AI-powered web application that allows users to upload documents automatically, scan them for compliance alignment. This system reduces manual effort and supports faster, more accurate decision-making. Here is what our system successfully achieved. We built an AI-based platform that can analyze and compare uploaded documents with a high degree of accuracy. The tool identifies clause similarities, highlights compliance gaps, and provides clear classification labels for each clause. It also produces visual summaries that makes results easy to interpret. Additionally, the architect is scalable and maintainable, allowing future expansion and integrations into enterprise environments. First, users upload both the company policy and the relevant regulatory document. Next, the AI analyzes each file, extracting key clauses and understanding the context. The model then performs clause-to-clause comparisons, determining whether each regulatory requirement is satisfied by the company policy. Based on this comparison, the system aligns compliance labels such as satisfied and partially satisfied. Finally, the results are visualized through a dashboard, allowing users to quickly understand the compliance status of their documents.
So our system works with two main types of documents. These are company policies and regulatory frameworks, such as HIPAA. And these files can vary widely in lengths from anywhere from 50 to over 1,000 pages. And so how our app works is once documents are uploaded as PDFs, we extract the text and pass it through our GPT model, which cleans, summarizes, and breaks the text into meaningful clauses. And then the process text is then analyzed against regulatory requirements, and our model will then return a structured JSON result that our application visualizes. So for our three-step pipeline, this consisted of document processing, semantic analysis, and scoring. Key components of our project revolved around the document upload service, our AI analysis layer, clause comparison engine, and our visualization UI. And for our modernized tech stack, our backend and AI processing layer was built on Spring Boot and we also use Spring AI, OpenAI GPT-5. Our front end and user interface layer was built using React, Vite, and Tailwind CSS. We ran everything locally, so we used Docker Compose. For our user authentication, we used Firebase, and for file storage, we used AWS S3. And for running everything, we just used GitHub commands, and we ran everything on Google Cloud Run. So for our results, we measured both performance and the quality of the model's outputs. And so here our system achieves about an 86% accuracy rating with an average response time of under 6 seconds. And it also supports multiple regulatory frameworks, which helps with our end goal. And so here on the right is an example of the user or the output a user would see where the system provides things like overall compliance score, along with different category level breakdowns like access controls, audit controls, and data protection.
For our local approach, we chose to implement a Python microservice. This microservice takes two text documents and returns the valid JSON schema for our front-end service. Some of the things we use to do this are embeddings for basic cosine similarity, natural language inference libraries for stricter classification, and a local LLM sourced by Hugging Face for final validation. So first we parse the compliance clauses, we match them using cosine similarity. We make these matchings stricter with natural language inference, excluding misclassifications. And for one final check, we pass to a local LLM source with Hugging Face. So some of the limitations for our application are we only support PDF files. We only support the English language. We have a 50 megabyte file size limit, and these results usually require a human to double check. Some of the local limits are on CPU bound runtimes. They approach about 40 minutes, and our local models underperform the OpenAI models in some cases. So some things we learned are prompt engineering is very powerful, and with the right prompt, you can improve the responses and the effectiveness of the model. We learned that local performance depends heavily on GPUs, and we learned that LLM APIs can be integrated into many places in web applications.
Lastly, we would like to thank George Sarkis and Kathy Martinez of Ottersoft and Dr. Fang for helping us out and mentoring us throughout the way. Lastly, I'll be doing a quick demonstration of the app. First, I'll sign in with Google Authentication. To start a scan, you go to the top right here, upload your company policy document and your compliance standard document. For a demonstration, we're going to use HIPAA. After finished scanning, to view results, you just press the button. Over here, we have an overall summary of what it's covering, what's partial, and what's missing. This breaks everything down by category, and this is a comprehensive summary of what strengths are, areas of improvement, and what you should do for next steps. Here's a detailed analysis you can download and view one by one. And to compare the two documents manually, you can just go here and scroll through the pages and do that. If you also want to download the results in a CSV file, you can click the top right here. It downloads to your local machine, and this export tab is used as a resource for anyone to re-download their past downloaded CSV files. Here we also have a couple of settings to enhance the user experience. But yeah, that's pretty much it. Thank you.